Hello everyone, this video is brought to you by the Atılım University OpenCourseware project for the course Physics 101. The lecture notes are prepared by Associate Professor Dr. Hüseyin Oymak and the video lectures are prepared by Ümit Alkuş. In this video, we will solve one problem in Chapter 10. A solid ball of mass m equals 1 kilogram and radius r equals 5 centimeters rolls without slipping on the inside surface of a hemisphere of radius capital R equals 80 centimeters. If the ball is released at point A, find its linear and angular speeds as it passes point B. The rotational inertia of the ball is given by 2/5 times mass m times radius r squared. Let's write the given quantities in SI units as radius r equals 5 centimeters, which is a non-SI unit, which is converted into meters as 0.05 meters, and radius of the hemisphere shown by capital R equals 80 centimeters, which is converted into meters as 0.8 meters, and mass is given by 1 kilogram. Angle theta is given as 40 degrees and the rotational inertia of the ball shown by capital I is 2/5 m times r squared. When the ball is at point B, we have this configuration. Now we take the rotational axle of the ball as the reference level at which the gravitational potential energy is 0. From this figure, the initial height of the ball is h equals capital R minus r times cosine theta. Now, in order to find the linear and angular speeds, we use the conservation of mechanical energy between points A and B. At point A, mechanical energy is purely potential energy, which is m times g times h. And at point B, the mechanical energy is purely kinetic energy, which is 1/2 times m times v squared plus 1/2 times I times omega squared. Since v is the linear speed, then the first part is the translational or linear kinetic energy, and since omega is the angular speed, then the second part is the rotational kinetic energy. Before continuing, let us introduce the condition for rolling without slipping, which is linear speed v equals omega times r. Then put the expressions for h and the rotational inertia of the ball into this equation. We get m times g times capital R minus r times cosine theta equals 1/2 times m times v squared plus 1/2 times 2/5 times m times r squared times omega squared, or 1/2 times m times v squared plus 1/5 times m times r times omega squared. And since r times omega is v, then we obtain 1/2 times m times v squared plus 1/5 times m times v squared. Then the final result is 7/10 m times v squared. Now m's at both sides are cancelled to give rise to g times capital R minus R times cosine theta equals 7/10 times v squared. And since we are asked to find the linear speed, the expression for v is calculated to be v equals square root of 10/7 times g times capital R minus R times cosine theta. Inserting the numerical values into this expression, we obtain v equals square root of 10/7 times 9.8 meters per second squared times 0.8 meters minus 0.05 meters times cosine of angle 40 degrees, which results in 2.8361 meters per second in 5 digits. However, in 3 digits, it is approximately 2.84 meters per second. Finally, the angular speed is found by the formula omega equals v over r. And put the numerical value for v that we have just obtained, 2.8361 meters per second, and the radius of the ball, that is 0.05 meters, then we obtain approximately 56.7 radians per second. Okay, this is the end of the solution of this problem. Thank you for your attention and see you in the next video.